In this video, we're learning about the day, the night, and the seasons. So we'll cover what causes day and night, as well as what the seasons are and what causes them. Let's start by looking at what causes day and night. To understand this, first we need to know that the Earth is constantly spinning around on something that we call an axis. This axis is an imaginary line that runs all the way through the Earth, from the North Pole to the South Pole. Now, if you look at the Earth relative to the Sun, something important is that the Earth's axis isn't actually straight up and down. Instead, it's tilted at a slight angle, about 23.5 degrees from the vertical. The Earth spins around this axis once every 24 hours, and we call this spinning motion a rotation. So basically, it takes 24 hours for the Earth to make one full rotation. Because of this rotation, different parts of the Earth face the Sun at different times. For instance, if we're standing here on the Earth, because our part of the Earth is facing the Sun, it would be day for us. This is because the Sun's rays are shining over this side of the Earth, making it light and warm. But then, when the Earth is spun around so that our part is facing away from the Sun, it would then be night for us. This is because we're shaded from the Sun and none of the Sun's rays are reaching us, making it dark and cool. Next, let's look at what the seasons are and what causes them.
As an example, in the UK, they experience 4 distinct seasons: summer, fall, winter, and spring, and these seasons cycle continuously, occurring at the same time each year.
Depending on the season, though, we experience either longer days or shorter days, and higher temperatures or lower temperatures. For instance, in the summer, we typically have long days and short nights, and the temperature is hotter, while in the winter, we usually have short days and long nights, and the temperature is colder. However, not all places on Earth experience the seasons the same way. Some places have basically no change in temperature across summer or winter, and the days stay almost exactly the same length all year round. To understand why this is, let's grab ourselves a sun and Earth, and break down exactly why seasons occur and why different places experience the seasons so differently. Before we begin, let's recap a few basics. First, remember that the Earth is tilted at an angle relative to the Sun and is always spinning around its axis, which gives us the day and night cycle. Second, scientists draw an imaginary line at a right angle to the axis, called the equator, and split the Earth into 2 halves. The top half is the northern hemisphere, and the bottom one is the southern hemisphere. Thirdly, remember that the Earth orbits the Sun, completing one orbit every year, which is approximately every 365 days. Now, if we look at our Earth, we can see that because of the tilt, the northern hemisphere is tilted slightly towards the Sun, and the southern hemisphere is tilted slightly away. Because of this, at this point in time, the northern hemisphere is experiencing summer, and the southern hemisphere is experiencing winter. Okay, so let's see why the northern hemisphere is in summer here and the southern hemisphere isn't. If we stick a marker here in the northern hemisphere and here in the southern hemisphere, you can see why the days are longer in summer than in winter. Because the Earth is spinning at an angle, the marker in the northern hemisphere is getting a lot more time in the sun than the southern hemisphere one. The longer days and shorter nights during summer are part of the reason why temperatures are higher than in the winter. Countries in summer heat up more during the longer days and cool down less during shorter nights, compared to countries in winter. However, as well as the longer days, sunlight is more powerful during summer than it is in winter. This extra power is also caused by the Earth's tilt, and to understand how it works, imagine rays of sunlight traveling from the Sun and hitting the northern hemisphere. We can see that 3 evenly spaced rays take up this small area on the surface of the Earth. But if we look at 3 rays that travel and hit the southern hemisphere, it's clear that they get spread over a much wider area. This means that the sunlight is basically less concentrated down here, which makes its heating effect less intense than it is up in the northern hemisphere, where the rays are more concentrated. So now, to complete the explanation, let's follow our Earth as it orbits to the other side of the Sun, and you can see how everything gets reversed. The northern hemisphere is now tilted away from the Sun, so is experiencing winter, and the southern hemisphere is tilted towards the sun, so is experiencing summer. So then, as you'd expect, it's now the southern hemisphere that's experiencing longer days. And if we add on our light rays, you can now see how the northern hemisphere sunlight is a lot less concentrated than the sunlight in the southern hemisphere as well.
We've obviously skipped over fall and spring here, but you just need to know that the temperatures are similar and the days are about the same length. When the Earth is here, the northern hemisphere is in fall and the southern hemisphere is in spring. And by the time the Earth has moved here, the northern hemisphere is in spring and the southern hemisphere is in fall.
Now, you might have noticed that if you're near the equator, you don't really experience seasons at all, because no matter where you are in the Earth's orbit, the equator gets about the same amount of sunlight. And finally, it's worth noting that the effects of the seasons get more extreme the closer you are to the North or South Pole. For example, at the Amundsen Scott South Pole Research Station in Antarctica, the sun never sets during the summer, and during the winter, it never rises.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.